Consider the two entities, books and authors. What is the relationship here? The simple answer is that each book has one author. Each author has many books. Therefore, this is a many-to-one relationship. But the world is weird and complex. This book here has two authors. Now, this is a many-to-many relationship. Each book can have many authors. Each author can have many books. How can we convert this from a many-to-many relationship? What we can do is we can add a junction table. The reason we need to add a junction table rather than just storing this is this field here would need to be a list of all of the authors for that book, and we just don't normally do that in SQL, in SQL. There are good technical reasons why we just don't store a giant list of authors in this row. Instead, we can add a junction table, and this goes between the two tables. Each of the original tables now has a one-to-many relationship. One book might have many entries in book author, but each row in this table called book author only lists one book. Here, I've called the junction table book author. If a book has 5 authors, then it will have 5 rows in this book author table. Let's have a look at example data to see how this works. So we have books and we have authors. Book number 1 is Good Omens. Book number 2 is Busting. Author number 1 is Terry Pratchett, and so on. The book author table looks like this. Now we can answer questions like, who wrote Good Omens? Well, Good Omens is book number 1, and it was written by author number 1 and author number 2. We can look in this table to see which rows have a book ID of book number 1 and find the authors for book ID number 1. Note that it has 2 rows in the book author table because it has 2 authors. This book here, book number 1, has 2 rows in this table. We can also answer questions like, which books did Aaron Blabey write? Well, Aaron Blabey is author number 3, and he wrote, let's look at book author. Author ID equals 3, he wrote book number 2. Book number 2 is Busting. Part of the reason that we like to use a junction table for many-to-many relationships is that these queries are easier to build and very fast to run. It is also infinitely flexible. A book might have 1,000,000 authors or no authors at all. This database design can handle it all. Let's go back to the example from earlier, where we had students and subjects. This is a many-to-many relationship. The entity tables look like this, student and subject. To store this many-to-many relationship, we add a junction table in the middle called student-subject. This brings us to a question. How do you name the junction table? The easiest way is to concatenate the entity names together. When I say concatenate, I mean join together. For example, the junction table between student and subject, we can just call it student-subject. Sometimes there is a more sensible name for the junction table. For example, a student-subject link, maybe it makes sense to call that an enrollment instead, so that we've got a sensible name for this junction table. One subject might have 10 enrollments, which means that there are 10 students in that subject. One student might have 5 enrollments, which means that they are in 5 subjects. Finally, let's consider, what are the possibilities for a primary key in the junction table? A common and straightforward approach is to just use a composite key corresponding to the primary key for each of the 2 entity tables. In other words, student ID and subject ID together will be the primary key for this table. What that means is that a particular enrollment can only be in here once. An alternative is to add an ID auto increment field. So add another field called ID and use that as the primary key. The advantage of that is that you can have the same student and subject enrollment appear many times. For enrollments, maybe it doesn't make sense, But if this is a junction table that lists the purchases of a product, it makes sense that a given user could order a given product many times. So I hope this has been helpful. Please reach out to me if you need a hand. If you haven't seen it already, do check out my video, Database Design, Entity Relationship Diagrams, for more detail on how to draw these relationships and these data types. All right, good luck everyone. See you next time.